In this part, we're going to talk about what is electricity. So here I've pulled up the periodic table of elements. So this is a table that shows what everything is made out of. And I say here, elements are made up of smaller particles. So you say an element is like oxygen here, O. And it's made out of smaller particles, protons, neutrons, and electrons. And so protons are in the center of the element. So if we could just say here's an element, and we'll represent this as the nucleus, and this is the outer electrons. And so the proton's in the nucleus. So each proton carries a positive charge. So for every proton you have a positive charge. And I say each neutron has no charge, so that's another thing that's in the nucleus of an atom. And then each electron, which is out here, in its each electron has a negative charge. Okay, so we have oxygen right here, and so it's going to have 8 protons in the nucleus, and then 8 electrons around it. And then some neutrons inside there too. Okay, and so here I've shown hydrogen atom, and it has 1 proton and 1 electron. Then I have copper atom, it has 29 protons, 34 neutrons in the nucleus, and then all these 29 electrons. And here I've said the heavier, denser nucleus of the atom does not move, but the lighter outer electrons can, or do. So electricity is the movement of negatively charged electrons in a material. Okay? And so we have basically 3 types of materials. We have conductors, and here I've circled it with the yellow because that's one of those things that you need to define. So in a conductor, electricity easily flows. So that's the negative part of negative electrons. Electricity easily flows in them. And some examples are silver, copper, aluminum, iron. Okay. Then we have insulators, and I say here electricity does not flow easily in them. And so dry air, wood, glass, rubber, plastic, paper are examples. And so what I say here is the outer electrons, and remember there was like 29, and what was it, like copper here at 29. The outer electrons in an insulator are usually tied up in what's called a chemical bond, and so cannot move around easily. And then we have a third class of stuff called semiconductors, and depending on the situation can act as an insulator or a conductor. And some typical examples that you would see was germanium and silicon, and I even put water here, because if you have super pure water, it would actually be non-conductive, but that's almost never the case. Water almost always has something dissolved in it, so in reality, water is almost always a conductor because it has stuff dissolved in it, ions in it, which facilitates the transfer of electricity. Okay, the next one is static electricity, which is a particular type of electricity. So I say static electricity is a form of electricity that occurs through rubbing off electrons where charge separation occurs. So like I said before, you have an atom, and it has, how many protons you have in here? Say you had 2 protons here, and then you have 2 electrons. Well, if you rubbed it, you could create a situation where you rub off an electron. And here an example is you drag your shoes on the carpet, and you rub off electrons from the carpet onto you, and so now you're charged here, and maybe you're wearing some rubber tennis shoes that insulate you so the charge doesn't run off very easily. And then you go touch a doorknob or a piece of metal, or and you get shocked as there's a little arc. And here I say lightning is a form of static electricity. And so here I've shown this is a cloud here, and you have charge separation happening. You have plus on the minus charge on the bottom and plus on the top. And most of the time when you see lightning, it's actually a discharge from one cloud to another and not to the ground. So if we have another cloud here, but it can go to the ground also.